In Chapter 1, we're going to be looking at one variable data. And in the first section, we're going to be looking at categorical variables and how you can represent them with graphs. So when we're looking at statistics, it is the study of data. And when we're looking at data, it contains information about a group of individuals. And then that information is organized using variables. So when we say individuals, these are objects described by the set of data. And it can be people, but it can also be animals or inanimate objects. Variables are then the characteristics of those individuals. So it can take on different values of different variables, and those variables can be split into two different types: categorical or quantitative. So categorical variables place individuals into specific groups. So the way I like to think about categorical variables are not numbers. So categorical is usually descriptive in some way. So for example, gender is categorical. Colors are categorical. And then you can also do size, such as, if you're looking at small, medium, large. So that can be size related to food, clothing, if you're describing an animal of some sort. So this is a very wide range when we talk about size. And then with quantitative variables, they take on numerical values for which it makes sense to do arithmetic operations like adding and averaging. So it's very important here that when we talk about quantitative, it's not just a number. It has to be a number where it makes sense that if I can find the average. So for example, height and weight are two of the very common quantitative variables. And then age is also quantitative. I can use numbers to describe all three of those things. Now, within quantitative variables themselves, there are two then categories, and that's discrete and continuous. One key thing I do want to point out here, I kind of went over it already, is that just because something is a number does not automatically make it quantitative. So for example, depending on where you live, you all have your own zip code. Now, it would not make sense if I took the zip code for Delaware, Lewis Center, Powell, one of the ones from Westerville, added them all together and divided and got another number, because that number I got wouldn't indicate a specific area. And if it did, it may not even be Ohio. So zip code, even though it's represented by a number, not quantitative. Also, in terms of animals, specifically animals that people show at the fair or are kept at the zoo, they usually have some type of animal ID that is usually kept either embedded in the animal and a tag in their ear, and usually that ID contains numbers. And it wouldn't make sense if we looked at animal IDs and added them all together and found an average, what that would look like either. So within our quantitative variables, we have discrete or continuous. So discrete variables are numerical values where counting makes sense. So in other words, decimals would not be an appropriate way to record the data. It doesn't necessarily mean that it can't contain decimals. It can contain very specific decimals. So one of the ones I like to look at is shoe size as an example of discrete. So shoe size, even though it can take on decimals of 0.5, it can only take on that decimal exactly. Another thing is if you're looking at the number of something, so like the number of siblings you have or the number of pets you have. So number of people. So if you're looking at people or animals, it wouldn't make sense to have a decimal number of people or a decimal number of animals. Every person is a person, every animal is an animal. You can't have decimals of those. And then thirdly, so something to get a little bit more medical on you, is blood pressure. So blood pressure is a number over a number, has to do with your heartbeat and two different measures of heartbeat. So blood pressure, usually a number like 100 over 40. It wouldn't make sense if I took everyone's blood pressure in class and then averaged it together. It wouldn't make sense to do that to get an average blood pressure. Next, we have continuous variables. So these are numerical values where decimals are appropriate. So you're usually measuring something. So continuous variables can take on any value in a range. So for example, if you're asking if you want to figure out how tall the class is on average, or the weight, so height and weight, two very common examples of continuous variables. And then we can also use time. So time can take on decimals, and you can represent it with a decimal, no problem. You can look at hours, minutes, seconds, so on and so forth. So for example, the difference between the discrete and continuous isn't always clear. So for instance, is age continuous or discrete? You use whole numbers to describe it, but you can measure decimal with an age. And sometimes, like age, the context in which you're using it is important. So if I'm just saying to someone my age, I'm not going to use a decimal. I'm not going to say I'm 16.4. So in that case, we would treat age as a discrete variable. But if I were given a list of people's ages and wanted to find the average, my average could come out as a decimal, and that would make sense in that instance. So when we're collecting age, we typically don't use a decimal. But if we're describing a data set about age, we might. Okay. Next, we're going to look at ways you can represent categorical data. And the first way is a table. So what I did is I took 21 responses from the welcome questionnaire that asked about gender and favorite movie genre. And for 21 responses, I listed the movie genre and then the corresponding gender of that person. So we have suspense, action, horror, mystery. We've got history, scary, rom-com, romance, comedy, fantasy, spy, sad, and thriller as our different, just in this list of 21. What I can now do with that is find other ways to display the data in tables, and then we're also going to look at graphs. If you need to finish writing down the table at this point, I would pause the video, finish filling out, and then continue. Okay. So one way, so like if I'm looking at the table how it currently is on the previous page, with just the list of the movie genres and then the gender. It's a little bit difficult to gather information other than maybe what the most popular gender is in the list, which is female. But I can't really tell what the favorite movie genre is, which one is the least favorite, that sort of thing. So what we can then do is write tables broken down by specifically movie genre, and then we're also going to take a look at how we can break it down based on gender. So for the movie categories, I went ahead and I used the top 5, and then I made an other because I wasn't going to anticipate all the different ones I have. So, and then I counted up the number of people who responded. So for romance, there was 1 person. Comedy had 2. Action had 4. I considered horror and scary to be the same thing, and there were 4 people. Rom-com was 3, and then all of the others added up to 7. And then if I add all my counts together, I get 21, which is the total number of people who I used. When I do it based on gender, so what we're going to do is we're going to have, based on the movie category, we have female, and we have male. Then we have the frequency, and we have something that's called relative frequency, which we're going to go into these in a little bit more detail later on. So frequency is a very similar thing to count, is how often does it occur. So in our table, there are 18 female, and for male, there are 3. The relative frequency is then what percent of the data is represented by that frequency. So if I'm looking at 18, which in this case the total is 21, so I'm looking at 18 out of 21 being female, which is 85.7%. And then for male, that's the remaining percentage that gets us to 100, which is going to be 14.3%. Now, depending on the size of your sample, relative frequency may not be the best way. It also depends on how many categories you have. So in this case, only 2 categories and having such a small sample of 21, using a relative frequency like this maybe not the best way to display the data. It would have been better to go based off the movie category itself and not the gender. So that's one-way tables. Now, if we want to compare the variables together, we want to compare 2 categorical variables at a time, we would make a two-way table. So what I did is, and now I could have put the movie genres as my rows and the gender as the column. It really doesn't matter, but it made a little bit more sense here for the gender to be the rows. So I have my female and my male as my rows, and across the top I have my movie genres, and then I have, you notice at the bottom row in the far right column are totals. So I always like to start by filling out the totals of my table, because that way I know how much I have to add up to. So I know there were 18 females, 3 males. I know the total from each of my movie categories. Now I'm just going to go through and break those up versus male and female. So the one romance was a female. The comedy was 1 each, 1 female, 1 male. The action was split up 2 and 2, and that gets us our 3 males. So the rest, the horror/scary, the rom-com, and the other, were all females, and our males were 0. And a key thing here is that when I find the total in this bottom right box is the total of the row and the totals of the columns. So I have to make sure that it matches. So I know 18 plus 3 is 21, and then I just have to make sure that 1 plus 2 plus 4 plus 4 plus 3 plus 7 is also 21. If your totals don't match, then you need to look back and double check that you added correctly or that you filled in a box correctly. Okay. So looking at tables is a good way to visualize data, but an even better way to visualize is making graphs from our data. And we want to visualize these graphs to get a better idea of the distribution. And when we talk about a distribution of a variable, it tells us what values the variable takes and how often it takes these values. And distributions are not specific to categorical data. They also apply to quantitative. There's a couple different ways you can display categorical data: pie charts, and then bar graphs. And bar graphs are what we're going to take a look at. So when we're looking at a bar graph, there's a couple key characteristics you need to make sure you have. One is that you are labeling each axis clearly. And this goes for all graphs, not bar graphs. We want to make sure we're labeling the axes. And dependent on what we're doing, we also label the graph itself. The x-axis is going to contain the categorical variable, and the y-axis is going to display the counts or percentages if you're working with that. Next, each category has its own bar, and the bars cannot touch. A key thing here about that is that the bars cannot touch. We are going to take a look at histograms for categorical data, which are very similar to bar graphs, and those bars do touch, so it is important to distinguish between a bar graph and a histogram. And lastly, order is not important when creating your x-axis because it is categorical, it's not numerical, so the order in which you do it does not matter. So we're going to go ahead and create a bar graph for the movie categories. So just copied over the data that we had on the previous page, so for our movie categories and the count for each category. So I'm going to go ahead and create my x and y axes. My y-axis is going to be my count, and my x-axis is going to be the movie genre. Okay. I got to make sure my count goes at least as high as my biggest value. It can go higher than that, but it has to go at least as high, and you want to make sure you indicate the scale in some way. So whether that's labeling the first and the last number or labeling every 2 numbers, however you want to do it so that I know what your scale is. Okay. Now I'm going to go ahead and create my bars. So the first one is romance, which instead of spelling out the words, I'm just going to use a letter to represent. So romance has a count of 1, it's 1 bar. Comedy has 2. Action has 4. Horror and scary also have 4, which I'm going to indicate with a backslash. Rom-com has 3, which I'm going to indicate with an R in the C, and then all my other account for 7. Okay. Now, it is easy to see because we're just looking at one data and there's not a lot, which is the most common. So other is the biggest one, followed closely by action and horror / scary, like we can see. But when we're looking at a lot bigger sets of data, or maybe even comparing to, looking at their bar graphs is going to help us figure out some more information about the sets of data that we're looking at. Please let me know if you have any questions about anything that we talked about in the notes.